Hello, I'm going to talk about leaf aggregator and Taylor pattern for the system design and use cases when it can be applied and what are some considerations of using this pattern. So let's go to the topics. First of all, there would be a discussion of like what this pattern is and some typical use cases. Then we'd go through details of each leaf aggregator and Taylor and check some examples and talk a little bit about an integration with bigger systems, aka how to like use it in production. So the pattern, it consists of three microservices. There's a stateful leaf, typically for some indexes, which has some metadata about usually like some key value store mapping from some ID to some like metadata, and also does some simple ranking. So it's typically like memory heavy, but not CPU heavy. Stateless aggregator is another one. It's querying leaves and does more complex ranking. Typically, like probably like 10 years ago, it would often be like CPU based, but modern ones would more likely gonna be like GPU based. And then there is also stateless Taylor for querying real-time updates and updating the data in leaves, because leaves would typically reload data from some like data pipeline generated indexes, and like they would not process real time by themselves, unless your leaf is also like a source of truth. But oftentimes indexes are like for the speed, they sacrifice some of like consistency or like durability. So oftentimes it's beneficial to have leaf as like a separate service from the source of truth of data. And some typical use cases include some recommendations, for example, followers based on connections followers. For example, let's take a look at something like LinkedIn, where like you can follow people, but there can also be like mutual connections with them. And if like say your like mutual connection, maybe like a friend or coworker likes somebody content, then maybe you would like that too. And then like another use case can be like, for example, search. For example, there are posts based on various keywords which are included. You may want to find something, hey, what is a post or like most relevant posts which include one or several keywords. Let's go to the details of leaf. So it effectively caches some data for fast access. It's typically going to be some key value store, like in memory hash map or like Redis, etc. It's usually not going to be durable. It generally shouldn't be used as a source of truth for data. So you can use like some source of truth of data for this querying, but you would sacrifice some performance. And depending on the pricing model for systems, like you may end up with a big bill. Like, for example, some systems like DynamoDB from AWS, they like charge you based on like amount of queries or like reads, for example. So in this case, like generating some additional index with some data pipeline, maybe doing some scrape from time to time, and like loading the data in a separate service, like for indexing, can be like more beneficial and cheaper. And also during the ranking, you often want results to be available pretty fast, so performance matters. Leaves can be sharded using some micro shards, where the data is split into a lot of small pieces, small shards based on some like hash, and then like each leaf instance gets some portion of micro shards. Or another alternative is to use consistent hashing with a hashing ring. If you haven't heard of it, I suggest you check it out. There are a lot of materials on that. So then cold start of a leaf typically involves reading data from some periodic snapshots done by some data pipelines. They may like read data from some SQL database, which can be chosen as a source of truth for its like durability and ACID properties. Or maybe it does periodic snapshots on itself and we just like read those. And then like potentially we can also fetch real-time updates from a Tailor service, which we're gonna talk about in a bit. Technically, you don't even need real-time updates, and it can work just fine, but they give you that extra like advantage of and freshness in your suggestions. So for example, when somebody followed somebody, you might use the data like pretty quickly, and like for example, if like some like new very interesting like person or page appeared, and then like a lot of your connections started following them, like the faster you suggest this, to like to the user, the more like engagement you can generate, and the more like value you can provide to them faster. So real time generally matters, although it doesn't have to be precise, but more on this in a bit. And there also can be multiple types of leaves, like you can have some indexes for like connections, you can have indexes for just followers, etc. For the follower recommendations example, leaf can store, for example, edges from person to their followers, and we're actually gonna shard by follower vertex, not by the person, because then it makes it much easier to actually do the aggregation and ranking on the leaves. Then we can like kind of focus on target, and then like for example find how many mutual connections are there, and we pass the list of connections. If we shard by the person, then we need to query much more data, and we need to pass much more data through the network, which is not going to be efficient enough. So if, for example, if you have like hundreds of persons connections, and you have maybe like hundreds of follows, it can result in like a lot, maybe like tens of thousands, hundreds of thousands, maybe in some cases millions of followers of connections. So it's really important to have some initial pre-ranking and efficient way how to do this. And this ranking, for example, can be based on number of common connections and recency of those. So for Aggregator, it runs some more complex model with a lot of features on a more limited set of suggestions. So if leaves can like potentially evaluate maybe thousands or tens of thousands of suggestions, Aggregator would probably evaluate already like maybe hundreds of them. But it depends. Like with the modern hardware, it may often depend on like how much cost are you willing to pay and what's the trade-off of this. But important thing here to note is that order of magnitude for what Aggregator evaluates is significantly smaller than what Leaf evaluates. And running the same model on all suggestions would be like very expensive, or much more expensive than running it on limited set of suggestions, of course. That said, like initial model matters quite a lot. So like you need to evaluate what are some most important features and try to like do ranking based on them in the leaf. Then this model, like Aggregator, would probably be like CPU or GPU heavy. Like more recent models will most likely just gonna be on GPU, because like that's gonna become a go-to for like ranking. And CPU is probably like can be used for some more simple cases, but if you like evaluating something like, for example, ads recommendation system in some like competitive like online advertisement platform, then most likely you're gonna need to use GPU model. But for a system design interview, like you probably don't need to like go into like too many details on this specific part. Yeah, so then like yeah, maybe if you have an interview for some like machine learning position, maybe you would need to learn more. So this is more like oriented on more like generalist software position. So queries are done to all leaves, but there has to be some timeout. it can scale independently from leaves. It's like more like a stateful service where you can scale on demand, and like basically you can like it can be based on QPS. It can be also based like depending how you tune it, how many suggestions do you want to rank. For the follow recommendations example, aggregator can like pass in person's connection IDs, which can be used by leaves to like compute this like mutual like target follows or potential follows, do initial ranking, and return some part of the suggestions to the aggregator. As I was talking about that without this initial ranking, there would be way too many suggestions for aggregator to rank with a complex model. And without the timeout, there's going to be some exponential wait time. And so your last like one or two leaves would like take much longer to return their suggestions, like just statistically speaking. So that's why some timeout is important, and that's where like there's some difference. For example, if you would be like looking about durable system, then it's not like, or like very precise system, it's not going to be acceptable. But if you're looking about just recommendations and maybe potentially missing some candidates, maybe still okay when you consider the trade-off of like returning some results more like quickly. So in business use case, it probably run some A/B tests or do some offline analysis and try to answer what the trade-off is right to you. For Taylor, it's usually like a small service querying some messaging queue like Kafka, which would have some real-time updates. It may be sharded to map to specific leaf shards to minimize the connection count, because if you have like a lot of instances of like Taylor service talking to like every leaf, that can be like kind of m times n possible like connections. But if you like kind of co-shard them, you can minimize number of connections and make it more like linear-ish, depending on number of shards. It can also do some simple short-term aggregation depending on some kind of data. Yeah, like it can depend on specific example. So typically, if you encounter this in like a context of like a more specific problem, you can see if like it makes sense to like pre-aggregate the data before sending it to leaf, or maybe you just like take all messages and send some data to leaf like every time. For the following recommendations examples, there would be some stream of real-time updates with follows, unfollows, maybe establishing connections. You may decide that sometimes like just using partial data and reloading full data from by hot swapping from like every day or hour in the leaves is like more beneficial than like querying full data from Taylor. Like for example, just to talk about this one. So if you have like follow, it's usually like a simple one. It like would like generate for every like you still need to query connections of of the given connection and create updates for all of them, but also like establishing connection that can be like also like you need to query all follows of a new connection of all follows of another connection, and depending on how your data is structured, you may find that some of this may be like harder to like query or update. So you may decide to skip it, but generally like you, of course, you want to get as many updates as possible. In the integration with bigger systems, there are some considerations. So you need to do like some filtering of final results based on various like privacy settings or like user settings. And although some pre-filtering during ranking as well helps, but it's not a replacement for like some final filtering. And know that like, yeah, even like during the ranking, some filters can change, so you kind of want to respect them as much as possible. And then you also want to add some caching for final ranking results, increase availability and performance, but also you still want to do some filtering in real time once you like fetch the suggestion and compute what to like show to the user. Because yeah, if you computed it like, I don't know, 10 hours ago and cached it, like it's great that you have those suggestions, but maybe user settings has changed and you cannot just like do some privacy checks back then and just use the results now. You need to like redo those privacy checks before showing it to the user. Some data can be computed on the fly and passed to the aggregator, like by external systems. Although usually integration with Leaves is like more efficient. But like maybe for some prototyping, it can be like faster to just like pre-compute the data, or maybe it's like doesn't require complex indexes. So it all depends. Yeah, that probably would be it for today. I think like once you encounter some problem which involves some search or like ranking of any sort, or any sort where there is some applicability where you don't need like precise results but more like need some kind of relevant recommendations, think of aggregator leaf and tailor system. This at least can offer a good starting point of the conversation, and if the interviewer had something else in mind, they would guide you to that. But in any case, this knowledge can be like pretty helpful, and can give you like a lot of opportunities to talk about a relatively complex architecture as well, which is often what interviewers are looking for.